Okay, hi everyone. Hopefully everyone can hear me. Yeah, well, I should say g'day. G'day from Australia. Thanks for joining us. Whatever time it is for you, it's morning for me here, 8 a.m. My morning coffee is just kicking in, so bear with me. I'd like to start actually with a tradition that we have here in Australia. I'd like to start by acknowledging the traditional owners of the land from which I'm broadcasting, and I want to pay my respects to elders past and present. My name is Ashley Davis, and I'm the author of Bootstrapping Microservices, as Matt was saying. I'm super happy to be here today speaking to you, talking about microservices and Node.js. I'm just going to share my screen so you can see my slides and my contact details and all that other good stuff. And I'm just going to try and get my screen arranged so that I can actually see the chat and see the participant list, because I need to keep an eye on people and make sure I can check people in. So let me just get set up. Okay, that looks good. Cool. So you can see my contact details on every slide. Please feel free to note them down. Please feel free to reach out to me and talk to me. I'm pretty active on Twitter. You've got my public email address there as well, and you can see my details on LinkedIn as well. Okay, so this talk today, it's part of a series of 3 that I'm doing. They're going to be fairly short talks, or today's going to be a little bit longer. So the parts 2 and 3 of this series are probably going to be a little bit shorter than today. We'll see. And these talks are coming up over the next month. So depending on where you're watching this, on DC JavaScript or Coding Bootcamp, or I think there was another meetup, I've forgotten which one. Just check the meetup page for when the next talk is coming up. It's not going to be too far off. Today is part 1 of the series, and I'm talking about, I'm going to be giving an introduction to microservices, and I'm going to show you how simple it can be to build a basic microservice with Node.js. In part 2 of the talk series, I'm going to amp it up basically from a single microservice to multiple microservices. And we're going to talk about testing microservices and developing microservices and actually running a multi-microservice application on your desktop computer using Docker Compose. And then in the final part of the series, I'm going to be talking about how to deploy your microservices to production using Kubernetes. So I've just got to check for people waiting to get in every few moments. So if you see me stop for a moment, I'm just letting people in. I'll start with a bit about myself. Matt did a nice little intro, but I'll hopefully expand on that a little bit more. I'm the CTO of Sortle, and we have a product that helps you organize your digital assets using the magic of machine learning. I'm also the developer of DataForge Notebook. It's like a Jupyter Notebook, but for TypeScript and JavaScript. And you can prototype your code with live visualizations and then later export your code to use in production. As I said, also, I'm the author of 2 books for Manning, Data Wrangling with JavaScript, which is basically a book that shows you that if you're a JavaScript developer, you probably don't need Python to work with data. Like most of what you need to work with data is already in JavaScript. You just need to learn how to do it. And that's what's in my book, Data Wrangling with JavaScript. And of course, there's my book, Bootstrapping Microservices, which has just gone to print like in the last couple of months. So I'm very proud and very happy to kind of have this out. There's a link on screen if you want to have a look at the webpage for it. You can read the first chapter free through that link. And I've got some books to give away at the end. So please make it to the end of the talk, and I'm going to do a random giveaway. And for the rest of you who don't get a random giveaway, I will have a discount code for you as well. So you can get the book for a little bit cheaper. Hang on a sec. I've just got a couple of people to let in. So this book, Bootstrapping Microservices, it's a practical and project-based guide to building applications with microservices. I start very simply in the book by showing you how to build, one microservice and package it and publish it and get it ready for deployment to production. And then it amps up to multiple microservices using Docker Compose, and eventually you get your microservice running in production on Kubernetes. So it takes you through the whole process from literally nothing to having a working microservices application in production, using an interesting example application called FlixTube, which is like an imaginary video streaming service that you're creating. But the recipes, the tools, the technologies, everything I cover in the book is basically, you can use that to build almost any microservices application. So it's very general purpose skills, very transferable skills that you're learning. So yeah, just please hang around to the end of the talk if you want to get a chance to win a free copy of this book. And the content you'll see in the talk today is very much similar to what's in the early chapters of the book. And in the second and third parts of this talk that are coming up later in the month, I'll be talking about some more advanced aspects that come up later in the book. So if you like what you see in this talk, if you like what you see in my other talks, you will find more of that in the book. And let's get on to it. So I'm going to start with an intro to microservices, and then I'll show you how to build a simple microservice in Node.js. Now, of course, ultimately I'm going to be using Docker to package and publish my microservice ready for deployment to production. Docker, you must have heard of it. It's that ubiquitous tool that's really changed it's really revolutionized our industry indeed. And Docker means that we're not limited to any particular tech stack. So we don't have to use Node.js or JavaScript to write microservices. That's not what I'm telling you. You can use any language to build microservices, right? So, feel free to use C#, Python, Java, Ruby. You could even use C++ if you're a sucker for punishment. So you can build microservices in any tech stack using Docker. But my preference is to build microservices with Node.js and JavaScript. And I'm currently using Node.js to run microservices in production for my startup and also for multiple contracts that I've done over the last few years. So naturally, given my background, naturally when I present examples, and all the examples in my book are in JavaScript and Node.js, when I present examples, that's what I use, Node.js and JavaScript. Before we kind of get into what a microservices application is, let's look at the alternative. Let's look at the monolith, and that's what came before microservices, basically. It's called monolithic. Hang on a sec, I'm just going to let someone in. It's called monolithic because it is literally an entire application running in a single process. It's like a whole, it's a monolith. Traditionally, this is the most common approach to development, and it's actually still in common use. So you will see monoliths being used by companies. It's not something that's gone away. It's not something that will be completely replaced by microservices. Monoliths are good for what they're good for, and they have their place in our industry. Now, the typical wisdom is that building a monolith, it's easier to build than a microservices application. And that's true to some extent. But I also want to challenge that notion. With modern tools, a good automation, a commitment to a simple architecture, I think microservices are easier and cheaper to build than ever before. So the choice of whether to go microservices or monolith, it's something you need to consider carefully. It's not as simple as it used to be. Hang on a sec. I've lost the control of my slides. There we go. So what's so wrong with the monolith that we'd like to replace it with microservices? Now, there are good reasons to start with a monolith. It can be an easier starting point than microservices. That's for sure. It requires less technical skills. It can be a great starting point for prototyping or testing the validity of a new business. A monolith is a great option for a throwaway prototype. And also, if you're building an application that's always going to be small, like you don't plan it to grow, you don't want to evolve it or extend it over its lifetime, then a monolith can be the right choice from the start. So, there's a place for monoliths. I'm not saying throw out the monolith. But, there are problems with the monolith that will make you want to think carefully about starting with it. Now, a monolith might start very simple, but ultimately, like any modern application, whether it's a monolith or microservices, it is destined to become complex. You can't avoid that. You can't hide from complexity by creating a monolith. So don't use that as your excuse for choosing monolith over microservices. Monoliths are difficult to scale, both for scaling your dev team and scaling the performance of the application. They're difficult to restructure, and that's something that gets worse over time. They have a large deployment risk. So that is to say that when you update your monolith, when you release new code, if you break the code, you break your entire monolith and your customers have nothing. So that's the size of your deployment risk when you're releasing a monolith. Monoliths have a single large attack surface. So if an attacker breaks through, or a hacker, whatever, breaks through that single line of defense you have, they are on the inside of your application causing all sorts of havoc. Now, ultimately, though, the real problem is that it can be very difficult to move from monolith to microservices. You know, if you've started with a monolith and you later decide that it's too limiting and you want to kind of convert it to microservices. So once your business and your customers are dependent on your monolith, you have to move very carefully in order to restructure it to microservices. So the organization is going to need to update its technical skills. The developers are going to need, you know, a fair bit of discipline and commitment, and be able to follow a long-term strategy, because it can take, you know, if you're going to take a big monolith and refactor it to microservices, that could take some time. That could take years even. You're also going to need a great testing regime. So, you know, if you already have a monolith and you want to change it to microservices, don't even think about doing that unless you've got good testing in place. You know, you just need that. If you're making changes to it and you can't test that, you're in trouble. So you see, once you're dependent on a monolith, it can be extremely difficult to get away from it. Now, of course, you know, the other option you have, instead of making a monolith, is to make microservices. Now, what is a microservice? You know, I'll tell you more about the benefits of microservices in a moment, but let's just understand what a microservice is first, just in case this is a concept that's new to you. A microservice is a small independent software process with an independent deployment schedule. Now, why is it important that a microservice is small? Well, having small services minimizes our deployment risk. Having small services allows us to make small changes, small, iterative, incremental, and frequent changes. And small changes can be more easily tested as well. So we can use this to increase our pace of development. At the same time, we're mitigating our deployment risk. Why is it important for the process to be independent? Well, it's important for fault isolation. I'm going to talk more about that in a moment. Why is it important for the deployment to be independent? Well, it's so that separate services can have their own release schedule. It means that faster changing services can have more frequent updates, and it allows each team to manage the release cycle for their own microservices. And this is something that facilitates independent and scalable teams. Okay, so how small should a microservice be? Now, opinions will vary on this, but I have my own metric. I would say that a microservice should be small enough that you can rewrite it in a couple of days, or at most a couple of weeks. Okay, so, you know, if it takes you months to rewrite a microservice, it's not that small. It's not that micro, is it? It's more like a macro service, or, you know, something bigger. That we don't really have a name for those. So that brings us to the microservices application. And a microservices application is a distributed application composed of many tiny software processes. That's the microservices. And the microservices work together to build the features of the application. The processes typically communicate via the network. And a microservices application is just a special case of a distributed application, right? You know, these things have been around for years, and recently they've sort of evolved into this new architecture called microservices, where, you know, you take these distributed processes and you shrink them down to the micro level. So the real difference between monolith and microservices is that the monolith is just one large service, really. You can think of it as one large service, where microservices are many small services working together to achieve a whole application. So a question you might have is, why are microservices so popular now? because like I said, distributed applications have been around for a long time. They've been around for decades, so this isn't really new. But why have microservices suddenly hit the mainstream? Well, firstly, it's because now we have modern automatable tools, starting with Docker about 10 years ago, or a little bit less than 10 years ago, that revolutionized our industry. And since then we've just had, like, we're spoiled for choice in terms of good tools to use. And the important fact here is that the tools are automatable. Automation is really important, because when we have many small services, we're naturally going to end up with a lot of them. And we can only manage such a large amount of services if we can lean on automation. So automation is crucial, especially for small teams who want to scale themselves up to manage large applications. Also, now we have access to cheap and convenient cloud infrastructure that we didn't used to have. It used to be expensive to run microservices, especially if you had to create a virtual machine to run each microservice, like what I did when I first started building microservices. That's not a cheap way to run microservices. But now we have, container services and, software like Kubernetes that makes it a lot cheaper, a lot more cost effective to run microservices. And the final thing is the DevOps and the DevOps revolution and the infrastructure as code paradigm. I'm sure you guys hopefully have heard of this. DevOps, developers are now managing their own operations, responsible for the complete life cycle of the services that they work on. Infrastructure as code has turned application deployment into a coding task. And so, this is what allows, small teams to kind of own their own microservices all the way from concept, development, testing to production. They own the whole, a developer or a development team can own that whole life cycle of that process or that microservice. This is only possible because the services are small. The services have to be small enough that a single developer or a small team can manage them. You can't imagine, like, if it's a big established monolith, you need like a big team of developers to manage that. But if you've got microservices, you can have individual developers or small teams of developers managing single microservices or potentially groups of microservices. So small services, microservices, they're basically able to be managed by separate teams. And this is leading to more scalable organizational structures for companies that are using microservices. So in summary, microservices are popular now because we've just reached that point, that critical mass point, where in terms of cost, ease of use, ease of access, and automatability, microservices have become very accessible to the mainstream community, or the mainstream development community at least. And so naturally, we want to use microservices for all the benefits that they have to offer. And so that brings me to the benefits of microservices. Now, some people think that microservices make things more complex. That can be true. I can see how that can be true. But what I believe is that any application can grow complex. It doesn't matter how you build it. Eventually it's going to become complex, and we shouldn't fear complexity. I think that our primary jobs as developers is to manage the complexity that we create in order to solve problems. So as developers, as good developers, what we should be looking for are better ways to manage complexity. I'm just letting another person in. Microservices are an architectural style that helps us manage complexity. Like, that's what it is. Microservices, just think of it as a tool to manage complexity. It's not something that's just put in there to cause complexity. This can actively help us manage the complexity in our application. So even though a microservices application will become complex, and by the way, a microservices application doesn't have to start complex. It can start simple, I assure you. Despite what people say, I show you step by step how to start simply with microservices in my book, Bootstrapping Microservices. It can be done. You can start a microservices application from a very simple starting point, and then every step after that, every iteration of coding can be simple. But so, a microservices application, like any application, it will grow complex over time. But the microservices themselves, the architectural pattern that we're using to build the application is the means by which to manage the complexity. And what I mean is that if you look at any established microservice application that's big, it's going to look very complicated. There's going to be a lot of moving parts. But if you zoom in, so you've got the whole application. If you zoom into the level of any individual microservice, it should be simple. It should be understandable. You should be able to read the code, look at the interactions with other microservices, and understand what's going on. And that's what microservices are supposed to be. They're supposed to be small, simple, and understandable. Like that's what it needs to be to earn the name microservice. It's got to be small. It's got to be micro. So that means that any given body of code that makes up a microservice, you should be able to read that and understand it fairly quickly. And then zoom out again and look at the entire application. It can seem complex. It can seem overwhelming. But then zoom in on the microservice that you want to work on, and you can it's simple. It's understandable. It's easy to test. Microservices help us manage and compartmentalize the complexity in our application. So microservices, with microservices, we get a fine-grained control over the application. That means we get tight control over deployment, security, scalability, team structure, and so on. Basically everything is broken down into these small parts. And instead of having this one massive monolithic thing that, we've only got one thing that we can tune, we can fine tune all the separate parts of our application independently. Microservices allow us to compartmentalize the components in our application. And it's just like how bulkheads work in a ship, in a boat, to divide the boat into compartments. So, if the boat springs a leak, the bulkheads close, the compartments close up, and we isolate a failure or a problem into a particular compartment where it occurred. And the same thing is true of microservices. Should any given microservice fail, the failure can be limited to that one microservice. And it doesn't have to bring down any other services. It doesn't have to bring down the application, and it doesn't have to cause disruption to our customers, which is the most important thing. The fact that any given service is small and we can roll it out independently means that our deployment risk is low. So when we deploy a microservice, we're risking just breaking like a tiny part of our bigger application. If we're deploying a monolith, on the other hand, we're deploying the whole thing at once, and we risk breaking the whole thing at once, which isn't good for anyone. Microservices support a scalable team structure. So the application can be split into many separate code repositories that are managed by separate teams and are independent of each other. And so because those teams are independent and they can work in parallel, and they're not treading on each other's toes. This allows us to scale up the size of our application and effectively distribute the workload across our growing company. Now, this is the most famous aspect of microservices. They are scalable in a performance sense. When you are deploying a monolith, you only have the one thing that you can scale, and it's not very focused. There might only be a small part of that monolith that you want to scale, but you're forced to scale the whole thing. And so it's not very cost effective. It can get very expensive. With microservices, though, you have more options for scaling. The application is already split up into these components, and you can choose to scale only those parts of the application that have a performance problem. So our scaling can be very focused when we're working with microservices, and it allows us a much tighter control over our running costs. Elastic scaling also works better with microservices because microservices are smaller. Because they're smaller, basically we can spin them up quicker to meet growing demand, and we can spin them down when that demand is gone. So again, we can really focus our scaling, and it can be much more cost effective. Now, this last thing on my list here, I want to mention, it might not be as obvious to people who are listening in. We can use microservices to isolate and control our technical debt. So instead of having one huge monolith-sized ball of mud, we can divide it up to separate islands, maybe separate islands of mud, that are independent and distinct from each other. So instead of having like one big pile of spaghetti, we get it all nicely separated out at the application level. And I actually think this makes microservices really good for prototyping and building MVPs, because you don't have to worry so much about the quality of the code, because you can easily and iteratively replace microservices over time with better code. And yeah, so it makes microservices great for building MVPs for startups. And I recommend microservices to startups. Given depending on their situation and what they're trying to achieve, of course, it's not right for everyone. But microservices, I do think they're really good for prototyping and MVPs, and that might be a controversial opinion, but that's what I believe. And I've been using microservices for startups for a few years now, so I've been through it. Now, the ability to replace microservices over time and improve our code, this is called designing for disposability. So we're using microservices. We're basically intending to replace our microservices over time to evolve and improve our application. We're effectively building in an ability to change, and that's really important in modern times when things are changing quickly, and any modern business has to kind of change quickly and adapt to survive or be competitive. Microservices can help us achieve that. So after all this, let's get to Node.js. Why use Node.js for microservices? I mentioned already that we can, we're going to be using Docker, so we can use any tech stack, we can use any language to build microservices. It doesn't have to be Node.js or JavaScript. But to start with, even though JavaScript, I don't think it's the world's best programming language. That would be hard to say, but I do truly believe that JavaScript is the world's most practical language. You can do almost anything in JavaScript. Using Node.js means you can go truly full stack. It means you can go anywhere in your tech stack, anywhere in your application without changing languages. Now, personally, I use JavaScript. Well, actually, mostly I use TypeScript now. But I use it for front ends, back ends, mobile apps, and more. Like I literally use, at this point in my career, I've been a developer for over 20 years. I've used many different languages. At this point, like I'm full-time, I guess I would say I'm a full-time TypeScript coder now. I never thought I'd get to that point, but I love it. I love being able to go anywhere in the application and just be comfortable. Just be comfortable with a language and the way it works and everything that's there. Node.js, for its part, it was made for building distributed applications. You may not realize this, but the name Node, that indicates that Node is intended to be a node in a network-oriented application. Node.js is network-oriented from the start, so it includes everything you need to build network-oriented applications. And the fact that Node.js was built for this kind of thing means that building microservices with Node.js, it's particularly easy. I'm going to give you a live demo in a moment, so hold on. You will see some coding in a moment. And passing data between services or Node.js microservices is particularly easy. And that's because the de facto standard for communication between services on the internet is JSON. And that's something that was born from JavaScript, and indeed it is built into JavaScript. I think there's plenty of other benefits to working with JavaScript that I'm not going to worry about today. I'm sure you guys are here probably already interested in JavaScript and know something about it, so I'm not going to go into bore you with details on that. But there we go. Sorry, this last one here. I guess you probably already noticed that Node.js has a huge community. There are lots of tools, lots of examples, lots of libraries, tutorials, plenty of books, plenty of resources for you to learn. And that's important. You're not working on something that's obscure or small. You're working on something that's big, popular, and has a lot of people. There's a lot of people that you can lean on if you need support, if you need help. Reach out, ask the community. They're very willing to help and guide you through the process of using JavaScript and using Node.js. So just before we get on to the demo, I'll just quickly cover the basic needs of a microservice. A typical microservice needs a way to communicate with other microservices and possibly also the outside world. It also needs a way to store persistent data. Typically we'll use a database, or we'll need to store some files in some sort of file storage repository. Today we're going to look at how to make a simple microservice. We're going to give it the most basic communication facilities. In the next talk, in this series of talk, we're going to explore some more advanced communication technologies. but today we're just going to keep it simple. And we're not going to cover storage today either. So we're going to look at databases and file storage probably in talk 2 or maybe in talk 3, depending on the timing of those talks. So who's ready to look at some code? If you wouldn't mind, just start, commence your prayers to the demo gods that this all works out. So I'm just going to switch over to my command prompt here. Just give me a moment to get myself set up. Okay. So what are we doing here? So I'm running Node.js version 14.16.0. Now you can install Node.js for yourself if you haven't already. Go to the Node.js website, nodejs.org. You can download the latest version from here. I recommend if you want to run multiple versions of Node.js, I recommend using NVM. So Google NVM. That allows you to install and manage multiple separate versions of Node.js on the one computer. It's really awesome. Okay, so I'm going to build a really basic microservice. I'm actually working with Windows 10 here, but I've got Git for Windows installed, which gives me all the Linux commands. So I'm just going to make a new directory for my demo today, and I'm going to create a new Node.js project. So I'm creating a Node.js microservice from scratch. I just want to show you how simple it can be to go all the way through this process. It's going to be pretty basic. It's going to do basically nothing except hello world, but it will be a good starting point for a microservice. So I can start a new Node.js project using npm init. If I add the -y command, I get it filling out all the defaults for me. So this is going to create a package file for me. And a package file is basically, you can see it gets printed out here. It's the metadata for the Node.js project, and it records the dependencies and stuff like that. So you can see that this is what an empty Node.js project looks like. It's just got a package file. Okay, I'm going to open Visual Studio Code from this directory. And I'm going to create a code file. So empty project, we've just got the package.json. There's nothing much in here, just all the details of the project. You can see here that the main file of the project is automatically set to index.js. So index.js is basically the conventional name for the main script file in a Node.js project. So let's create that. Let's say new file, index.js, and let's just start with hello world. Nothing too exciting yet, but we're going to build up. We're going to build up to something more complicated. So I saved that. I'll switch back to my terminal. I can run that now. I can run node index.js, and it prints hello world. So, that's the first stepping stone. Creating an empty Node.js project that just does hello world. Now, at this point, I could create a Git repository. Like, it would be pretty standard practice that if I was actually building a production microservice, I'd create a Git repository now and, potentially create one like a hosted repository on GitHub or Bitbucket or something like that and push it up there. Let's not worry about Git today. Let's not worry about Git. Let's just pretend that, I would be using that if this was a proper development process. But what I'm going to do is I'm going to make a start command in my package.json. So this is an npm an npm convention really, but it's a Node.js convention as well, where we create a start command that tells it how to start our application. And so now what we can do is you can just run, instead of running what I did before, node index, now we can run npm start. So this is the conventional way to start a Node.js application, is to run npm start. And then it's configured in package.json to run, whatever your main file happens to be, whatever that happens to be, you include that there. And you could possibly also include, configuration of environment variables here, or command line parameters that you need, or whatever. Now, what we need to build a microservice, or the basic functionality we need is to have communication with other microservices. So we need a way to accept messages or commands from other microservices, and we need a way to send messages or commands out to other microservices. Now, as I said before, everything you need is included in Node.js. You don't actually need to install any dependencies or any other packages or libraries or anything like that. But that said, it can be a bit more complicated, a bit more nuts and bolts, boilerplate code and all that, to configure the Node.js standard library to do what you want. So typically we're going to install, some projects, some NPM packages to help us to move faster, basically, to make our lives a little bit easier. And typically I use Express to start with. So that is a REST API or a web server framework. It's one of many. There are many different, there are many different packages you could use to do this. Another one I've tried is Happy. But Express is the de facto standard for building REST APIs in JavaScript. So it's a good starting point, and it's mostly what I've used in production, and I think it's pretty good. And like I said, you don't need Express. You can do everything you need to do with the Node.js standard library, but something like Express just makes it that little bit easier. So that's how Express is basically how we're going to be able to accept, incoming commands, incoming messages, incoming queries from other services and the outside world. And the other thing we need is a way to kind of send these messages out, which I'm going to use Axios for that. And again, you can do all this with Node.js, but Axios just makes it a little bit easier to send outgoing requests. So I'm installing both of those things. They're coming down from the NPM repository right now as we speak. And that was pretty quick. That's done already. So if we go back to Visual Studio Code and we look at the package file here, we can see in our dependencies now we've got Axios and Express installed. They get installed into the Node modules directory, but you can see we have a lot of stuff in the Node modules directory now, and that's because dependencies of dependencies as well get installed. So Express and Axios actually depend on a lot of the other packages themselves, and so it automatically brings all that in. So that's just under the Node modules directory there. Now, what I want to do at this point is put together basically a basic Express-based microservice. And the easiest way to do that is go to the Hello World example on the Express website, which I've got here already. So the Express website has this great getting started example, great documentation generally here. It's well worth reading through. I'm just going to copy that. And I'm gonna dunk it in my my index file here. Now, there's many different ways you could easily write this from scratch. It wouldn't take much effort to write this code from scratch. Or typically, what I would do, typically I write TypeScript microservices. So I have a TypeScript template on my GitHub. Please feel free to have a look at my GitHub. Ashley Davis, look for TypeScript template. That's a generic Node.js TypeScript project, so it's a good starting point. Normally, if I want to start a new TypeScript project, I just clone that and create a new repo out of it and start work on a new project from the template. But I'm just going to start from this simple Node.js Hello World example from their webpage. It simply prints Hello World when you hit the web server. So let's test that. So I can run this using npm start, and it puts the information here. So you can see that it's console logging that here. That's where that comes from. This bit here, it's console logging, the link to click on basically. And in Windows Terminal, you can just click on that link. And so we've got our little website now running that says Hello World. So not too exciting yet, but we're getting there. We're getting there. One thing I like to do at this point is get set up for live reload. So with live reload, that means I can change code and the microservice will just automatically restart by itself. Typically, I do that by installing, I install it as a dev dependency, not a production dependency. That's important. I install NodeMon. So NodeMon is kind of like a drop-in replacement for Node in a way, in that you can run your script file with NodeMon, but when any of your JavaScript files change, it's automatically going to reload your web server or your microservice or whatever it is. And I can run it just, instead of running node index.js, I can just edit that and run NodeMon instead. But actually, because I'm running it as a package from the current directory, I have to use the npx command to run that. But that's running now. It's running like it was before, except you can see that, if I change the code here, I'll get my code and my terminal side by side. I could change this to hello microservice. And that automatically restarts the code on the left here. So it's a great way of working, a really streamlined, fast and efficient way of working. It works great with TDD and automated testing because you can change code and have your tests automatically rerun, while you're coding it. It's such a powerful thing to be able to do. Now, what I want to do is get a script set up to run that as well. So I typically have my own convention to do this called start dev. This isn't a Node.js convention. It's just my own conventional name for that. And I usually just make it run nodemon index.js. So, no matter what, basically, no matter what microservice or Node.js project indeed that I'm in, to run it, I either run npm start. I don't have to remember anything, or that's like running it in production effectively. If I want to run it in development, sorry, it's npm run start dev, and so that's what's going to run nodemon. Now, what's next? Okay, so how do we configure a microservice? We need a way to configure this. We need a way to kind of say that, I might want to roll out a few different copies of this, or, I might want to roll this out into different clusters, and I want to configure it differently. And there's a bunch of ways you could configure a Node.js project. You could configure it with configuration files. You could configure it with command line parameters. But typically, the most common way of configuring a microservice or a container, as it were, is through environment variables. So I've got an example here. Let's say we want to configure the port. So this is running on port 3000, but we might want to run it on port 80. Typically, I'll run my microservices on port 80, which is the standard, the default for HTTP. So we can basically read an environment variable called port. Now we have to check whether that's undefined or not, whether it's actually being supplied, if I can spell properly, undefined. And if it's not undefined, we can parse that as an int. So let's just copy this into there. So we're parsing. So environment variables always come in as a string. So if we want them to be an int, we have to parse it as an int. And what I'm saying here is basically, if the port environment variable is not undefined, then we parse it as an int and use that as the port. Otherwise, we default to 3000. 3000 is a pretty good default. It's like a conventional port number for a web server running in development. It's going to save that. It's automatically restarted over here. You can see that it's automatically gone to port 5000 as well. And the reason for that is because I had previously set environment variable to 5000. But I can set that to anything, right? I'm on Windows, so I would use the set command and set my port number to say 4000. If you're on Linux or Mac OS, you'll use the export command instead, but it's the same thing basically. That's not going to work on Windows, so I'm not going to do that. So I've set that port number to 4000. If I restart now, you'll see that my thing is available on 4000 now. So we can configure this. Like I can configure this externally. So if this was built to a Docker image, I could deploy this as a container to a Kubernetes cluster, and I could tell it which port to run on. And I could configure anything, anything that needs to be configured within this microservice can be done through environment variables. And it's especially, in this case, it's optional. So in this case, I'm saying it's an optional to pass in the port, otherwise you get a default. But often it won't be optional. Like you imagine if you've got a microservice that talks to some external service like say Dropbox, and you need to kind of provide some authentication so that it can authenticate with Dropbox and however you integrate with that, whatever you want to do with that. But you need to pass in those credentials for Dropbox as environment variables. You don't want to hard code passwords and stuff like that into your code. That's a really bad idea. So you always want to pass, sensitive, secret stuff in through environment variables. And it's nice to provide a good error message as well if that doesn't exist. So if we were saying if we needed to have so the Dropbox credential passed in here, right? We're gonna authenticate with Dropbox and use its services somehow. But if that was let's say that was equal to undefined, let's just throw an error, right? You missed the environment, You know what I mean? Like you want to provide a good error message here that says that you did not include that environment or that thing that you were supposed to configure. So it's just nice that when you're rolling these things out to production, if you have forgotten to include the configuration, it's gonna throw an error and die, and you can go and look at the error log and find out like what was missing and then fix it. So that's just a brief look at how to configure a microservice. now we're going to look at basically how to make a request, or how to make send a message or a command to another microservice. Now, we don't even have another microservice running. We've just got this one microservice that we've just started. So, you know, practically there's nothing else that we can talk to yet. But what I'm going to do is I'm just going to fake it. So I'm actually, let's add a new route actually. So this is how you might handle a command coming into this microservice. Some command. It can be anything, right? It can be any name you want. It can indicate what's going to happen. There'll be a request and a response, and then yeah, you'll do something. You'll do some action here. Do the command, or whatever's being requested of this microservice. You know, it's going to read from its database, save to its database. You know, do some computation, do some calculation. Whatever is the job of this microservice, it's going to do it there. And eventually, you have to kind of send a response code. Otherwise, you just leave the client hanging. So you could return data, or you could just return a status code. Hopefully, that's the right thing. So let's just try this. So that's some command. Yep. So it's returning status OK. And if we look back at the console, you can see do the command. So we've essentially just instructed that microservice to do something. And I sent that request from the browser. But you can imagine, you know, in a real application, that request could be coming from a different microservice, or it could even be coming from like a webhook outside the application itself. Now, what I want to do here is kind of forward a command, or forward a query, or trigger, send a command to some of the microservice. That's what I'm going to use Axios for. So I'm going to use a HTTP GET request. And I've got an external service that I can use, that I like to use for prototyping, called JSON placeholder. Let me just grab the URL that I need, if I can find it. Oh, there we go. So I'm just copying across the URL for this thing. This is a placeholder REST API. So you can use this yourself if you want to practice using making requests to REST APIs. It's really cool. It gets you back a JSON list of to-dos. You could just imagine, let's just pretend that we're talking to the to-dos microservice, okay? Just to kind of set the scenario. So we're making a HTTP request using Axios, and then we're going to get the response. And let's just return the response directly to the requester, or I should say, we'll return the data in the response to the requester. And just to be good citizens, we'll handle the error. And if there was an error, we'll log it. An error occurred. And we'll actually print out the detail of the error itself. And then we're going to return an error status code. So it was error status 500, which means something went wrong in the back end. So I'm saving that. So now what I have is I have the ability to accept a command from some other microservice, send a command or send a query, or however you want to interpret this, to the to-dos microservice. Let's just pretend that that's what it is. Then we're returning the response to the client. And if there was a problem, we're doing an error code 500. The status code is implicit here. That automatically sends a status code 200, which means success. I'm going to switch back to the browser. If I run this again, I should see my list of to-dos. Let me just zoom out a bit so you can actually see that. So here we've got all the to-dos coming back, right? So you imagine, if this was a real microservice that was doing something, it might not be just returning data. Here, it might be doing some sort of transformation on the data, storing it into its own database or something like that. It could literally do anything that it wants. Now, there's not much here, right? Let's look at the whole code. I'll zoom out so you can see the whole code. This is like the basic code and the basic communication ability for a fledgling microservice. It's simple, but believe it or not, this is a great starting point for a Node.js microservice. There's different things that we would like to add to this to make it, to be able to do its job. We might need a database. We might need a way to store files and load files. That's something I'm going to talk about in part 2 of this talk. It's coming up later in the month. So I'm not going to talk about that today. And also, there are other ways that you want to communicate with other microservices. So at the moment, we're just using HTTP requests. to accept incoming requests and send outgoing requests, but we might also want to use some sort of asynchronous or indirect message queuing. And in part 2, I'm going to show you how to use RabbitMQ to do that. So that's a more advanced technique for communication between microservices. But we're keeping it basic, we're keeping it simple today, and I'm going to wrap up soon, so I need to move on. But the last thing I want to show you is how do we get this into a Docker image and then boot a Docker container. So we need Docker. Like, why do we need Docker? It's because we need a way to package this. We need a way to publish this so we can deploy it to production. And that's the problems that Docker solves for us. Let's just save this code. So I'm going to stop this running in my terminal because I'm going to use it to build Docker in a second. And now I have a couple of Docker images downloaded already. If I do a Docker image ls, that shows you that I've got Node 14 and Node 14 Alpine downloaded already. I would have liked to have started this demo with nothing and to show you how you get everything from scratch. But unfortunately, these images take a while to download, and I don't want to waste your time, waiting for something to download. So I've pre-downloaded them, but they're the only images I've got locally. And I'm going to build an image now for this microservice. And in a minute, you will see it in this list. You will see that I've built the image and that it's available here. How do we do that? Well, to start with, we need a Docker file. And we just call that Docker file, literally just Docker file. That's the default name for this thing. Let's get rid of that. I don't need that. The other thing we should have in a Node.js project is a Docker, or any kind of Docker project probably needs the Docker ignore file. And this is just like the git ignore file, if you know what that is, or the npm ignore file, if you know what that is. It says what to ignore, not to pass to the Docker daemon, because it can be quite slow if, say, your whole node modules directory here gets copied into Docker. We don't need to do that. So we add node modules to Docker ignore. It won't matter on this small project, but it does start to matter when you start to get a bigger project with more dependencies installed. Like if you have megabytes of dependencies, you don't want all those being copied into the Docker daemon. Okay, the Docker file. So the Docker file is like a script that basically says how to build the Docker image for your microservice, or Docker's not just for microservices, obviously, but that's what I'm using it for. At the top of the Docker file, we say, where do we want to? What do we want to start with? What existing image do we want to base this on? And I will base this on Node 14 Alpine. Now it could just be Node 14, so that bases it on a Linux distribution that includes Node.js 14 already installed. So we've got our dependencies already installed in our image for Node.js. The Alpine version of that is just a cut down Linux distribution. It's better for production because it's a lot smaller. It's a lot smaller than the non-Alpine distribution. So that's why I'm using that. And typically we'll set a work directory. So this is the directory that I'm going to work with inside the image that I'm creating. And I think, this is just a sort of I guess a tradition that it's like app source app. Oh, sorry, user source app. If you do the Docker tutorials, I think that's what you get. And so that's probably why everyone uses that. I don't think there's any particular reason why it should be that. Then you start copying files. You start copying files into your image. So typically I want all my package files so I can install my dependencies. Now I'm going to run a command inside my image. So now just bear in mind here that I'm using Windows 10, but what I'm doing here is I'm doing things inside a Linux image. So it's a Linux image with Node.js installed. So I've definitely got to use, I've got access to all the Linux commands here, but anything I run here, like this npm install, I'm going to install my dependencies for my project. Anything I run is going to run inside the image. And I'm saying only install production dependencies here. So I don't want the dev dependencies, like the one I installed earlier was NodeMon, but you could have any other dependencies for testing or to help you with debugging or development, and you don't want to include them in your production build. So just make sure you only include your production dependencies. Now I've got one code file to copy. That's index.js. So I'm going to copy index.js into my image. Now, typically, I wouldn't do this. Typically, I'd have all my code in a source directory, and I just copy the whole folder of source code. But this is a simple microservice, and we're setting it up simply here. What do I do next? Just one more thing now. I need to give it the command to run when it starts the container. So when it boots a container from this image, when it's starting the microservice, what is the command that starts it? Well, it's just simply npm start. So that should be the command, no matter what Node.js project it is. That should be the command that you can use. If the developer of it has followed Node.js conventions, npm start is what starts it. So hopefully I've typed that in correctly with no issues. Let's build it. The simplest way to build a Docker image is to go to the directory where the Docker file is. So you can see that's the Docker file here that I just created. And then I'm going to run Docker. Oh, so let's look at the version of Docker I've got first. So I've got Docker version 2010.2. I've installed this using, in a sec, let's see. Sorry, just checking if there's anyone coming in. But so I've installed Docker desktop. You can get that. You can definitely get that for Mac and Windows. I don't know if you can get it for Linux. You might have to install it using apt-get for Linux, but that's okay. That's easy to do as well. With Windows 10 though, you have to install the WSL2 subsystem. So that basically allows you to run Linux on Windows under the hood as a virtual machine. It's not too difficult to set up, and it's totally worth it. It's totally worth it to be able to use Docker on Windows to install WSL2. And if you're working on Windows but you're a Linux fan, you'll love it. You will really love WSL2. Anyway, so to build this, the simplest thing to do in this directory is to run docker build dot. The dot's very important. That tells it to build against the Docker file in this current directory. So that's building now. You can see here it's running the commands like the copy command, and it's doing the npm install. So it's doing that npm install inside the image, and it's finished. So I should be able to do a Docker image ls now. I should be able to list the images that I've got. And you can see here that I've got a new image that was created 9 seconds ago. So that was what I just created then with the Docker build. I didn't name it, so it's got no name. I didn't put a version number on it, so it's got no tag. So you can do that fairly easily, and you have to do that if you want to publish it. I'm not going to publish this. I'm just going to build it and run it locally just to give you a taster. And I can run it now. I can say Docker run. Now, if I just use Docker run by itself, this will actually run it. You'll see that we now have a microservice, the one we just built, running under a Docker container. So it's running on Linux under Windows, which is incredible, really. But we can't access it. It's on port 3000, but we can't access it. And the reason is because it says localhost, but it's actually running in its own localhost, like basically in its own virtual computer. So the container is like a whole virtual computer, basically, that's running inside our real physical computer, but we can't directly access it. In order to be able to access it, I need to do some port forwarding. So I need to be able to map ports from the host operating system of Windows into the container, which is Linux. We do that using -p, and then we say what is the port number on the host operating system, and what is the port number in the virtual operating system. So this is going to start it again now, but now I should be able to access it on port 3000. So you can see I can run this now. This is the Hello World microservice, but it is running under a Docker container. It's not running directly under Node.js on my desktop computer. Hopefully that makes sense. So let's have one last look at this Docker file before we leave it. So this is it. This is a really simple Node.js project. We've built a really simple kind of REST API / web server. It's a great beginning for a microservice, and it's just super simple to put together. There's nothing to this. And then we've built the Docker file. So the Docker file allows us to create the image, which is basically the package. We're packaging up our microservice so that we can deploy it. Now we've tested it locally. We ran it locally, but ordinarily what we do at this point is we do something like a Docker push, and we tell it we want to push the image to our private container registry in the cloud, and from there we could publish it onto our production, Kubernetes cluster, or wherever we're running our containers. We're not going to do that today. We're going to do that. We're actually going to do deployment to production in part 3, coming up in about a month. So stay tuned. Wherever you found this this talk in the first place, go back to that meetup and sign up for the next talks as well. So we've done a little bit of coding. You've seen how easy it can be to put together a microservice in Node.js. And that's about it for today. You know, we've had the intro to microservices. We've seen how to build a simple microservice. In part 2 and 3, we're going to scale up to multiple microservices, and we're going to have a look at how to deploy our microservices to Kubernetes. So please join me for those talks coming up in the next month. And I'd just like to leave you with a link to my book, Bootstrapping Microservices. Again, you know, if you like what you've seen today, you'll find more of it in my book. It's a practical and project-based guide to learning microservices and actually getting a microservices application into production. I have 2 books to give away today. I'm going to give them away at random to people who are still here with me. But there's a code on screen. If you want to get 35% off, if you don't get a free book, use the code and get 35% off. I'd love it if you read my book. Okay, so I have got. I'm gonna find a random number generator that I had already loaded here somewhere. We currently have 16 participants, so I've got 2 books to give away. So you've got a pretty good chance of winning a copy of the book. I'm just going to get the participant list on screen. I don't know if you guys can see this. I'm just going to open the chat window as well if I can find it. Okay, cool. I can see the chat now. I've been sorry if there's been any questions during. I will get the questions in a second. Oh yeah, someone has asked a question. Shouldn't it be command, you know, square brackets, npm start? But you can do it either way. You can just put like a string-based command, or you can put like that array-based command. It doesn't matter. It's your choice. I don't really know if there's any benefit to doing it one way or the other. For me, I like it to look like you're running a normal command on the command line. So I use just like a string, and that's always worked well for me. Anyway, where's my random number generator that I had? Here we go. So we have 16 participants, and I'm about to roll the dice from 1 to 16. Let's count from 1 like we're normal people and not coders. So basically what I'm going to do is I'm going to generate this random number, and I'm going to count down the list, not including myself. Actually, I might be included in the 16. So yeah, I probably am. So let's make it. Let's just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So there is only 15 people, not including myself. So let's roll the dice and see who gets the book. 7. So that's 1, 2, 3, 4, 5, 6, 7. George Barnaby, you have won a copy of the book. Congratulations. I'm just going to write down your name so I remember to give you a code in a moment. So George Barnaby, please stay on the line. Don't leave the meeting until I give you a code for the book. Okay, let's roll the dice again and see who gets the other copy that I'm giving away today. Number 1, that's Tuba. Tuba, please stay online for a moment, and I'll give you a copy of the book in a moment. Awesome. Congratulations to those 2 who got a free copy of the book. I'll just stop the screen share now, and I'll get the chat back. Is there anyone who wants to ask a question? Let me see if there's any other questions in there. Someone said it shows me as number 1. Well, I don't know if you could see my list of participants. Like Zoom might have hidden that from you. But basically, like for everyone who's watching, you are probably in the number 1 slot. So sorry if that was confusing. I was counting down from the number in my list, basically, which I don't. It's not alphabetical order. I don't know what order it's in, but you know that's the way it goes. It was a random number generator. What time zone are you in? I am in Australian Eastern Standard Time Zone. I am in Brisbane, and it is It is just past 9 a.m. in the morning for me. Just looking through. Any other questions? Will the recording be shared? Yes, Matt has said that he will share the recording today, I think. So stay tuned. And I'll as soon as I have a recording as well, I will tweet about it. And I'll also be tweeting the slides and the slides and the example code as well. I'll put the example code on GitHub and share it with everyone. I haven't done that as yet, but I will do that later. And so keep an eye on my Twitter account. Keep an eye on, wherever you saw the meetup in the first place. Keep an eye there because you'll see the recording and the slides and the example code there. Okay, we've got some good questions coming up. How does the port forwarding work in a production environment? Well, that's a little bit more complicated, but it basically works the same way. Like I deploy to Kubernetes, and I will create a configuration file that allows me to deploy a container to Kubernetes. And similar to how I put, -p 3000:3000 on the command line just then, I'll put something similar in my Kubernetes configuration that does that port forwarding. But typically, I just expose my microservices on port 80, and I serve them on port 80. So there's nothing complicated that needs to be done. And I will show that. I think that will be part 3 of this series of talks coming up later in the month. I will actually show how to kind of deploy a microservice to production, and I will show how to do that port forwarding. Here's a question. In terms of data, how many tables does a sorry, I'm not sure what I'm reading here. Does a microservice should have, and how do we segregate functionalities? Do you, I guess you mean database tables? And the answer is, if you're talking about database tables, the microservice can have as many database tables as it needs or wants. There's no, there's no particular limit. It really depends on, what the microservice is, what data it needs to manage. And I haven't talked about databases in this talk at all. Like that's coming up, that's probably going to be coming up in part 2, where we kind of scale up to some more advanced topics. So please come back for talk 2, and I will show you how I would integrate a database into a microservice. But, a database, like a microservice, you usually follow the rule that a microservice should have its own database. You can share a database server between all your microservices, but each microservice should have its own database, but it can have as many tables in that database as it wants. There's a question here. What is the difference between RabbitMQ and Memcached? I don't know. I've heard of Memcached, and I think I read about it once, but I can't remember what it is. So I can't answer that. But RabbitMQ is like a messaging queue. So I'm going to be showing you how to use RabbitMQ in talk 2 of this series, because that's what I use. I use RabbitMQ in production. It basically means you can have indirect communication with other microservices, which typically means you want to publish a message, like publish a message that or broadcast a message that other microservices are interested in, but it's indirect. You don't really know if other microservices are handling that message. And it's a great way to kind of set up streams of messages between microservices. And I will give you hopefully a live demo of RabbitMQ if I can, if the demo gods let me do that in talk 2. Next question. You mentioned TypeScript. Can you contrast that to Express? They're 2 separate things, so they can't really be contrasted. So JavaScript and TypeScript can be contrasted. JavaScript is a dynamic language. And TypeScript builds on JavaScript to add static typing and a build phase and a compile phase. So using TypeScript allows you to kind of have like extra error checking on top of JavaScript that you wouldn't normally have. And if you come from a statically typed background, like if you are previously a C#, C++, or a Java developer, TypeScript basically adds those static typing features on top of JavaScript. So JavaScript doesn't normally have that. So you can think of TypeScript as like an add-on to JavaScript that kind of improves the development process. It can't be contrasted. It's like apples and oranges. It can't be contrasted to Express. You can use Express whether you're using JavaScript or TypeScript. It doesn't matter. They can't be contrasted really. In production, can you use a reverse proxy like Traffic? I haven't heard of Traffic, but one that's fairly common is Nginx, Nginx, I think they call it. that can be used as a web server, front end, or a proxy. A really good one, actually, that I've heard lots about in podcasts and I want to try out is called Envoy, and that's actually on the same level as Kubernetes, and it's a graduated open source project in the Cloud Native Computing Foundation. So if you're after a proxy versus proxy, you check out Envoy. That might be able to do what you want. Sorry, I can't, I can't say anything about traffic because I don't know about that. What else we got here? Oh, Memcache is similar to Redis. Cool. Yeah, I have used Redis. So what was the question? What is the difference between, let's say, what is the difference between RabbitMQ and Redis? They're completely different. So Redis is like an in-memory database designed for like caching data. So you might have like, if you have a regular database like SQL or MongoDB and it's slow to load, you might have the kind of loaded data go into a memory cache like Memcache, obviously, or Redis. RabbitMQ is for message queuing. So RabbitMQ is like, it's not a database. So it's not, in that case, it's not really comparable to Memcache. They're separate separate software for separate purposes. How do we handle cross-cutting concerns like security, distributed logging, and tracing? And are there any packages that we can import and provide out-of-the-box support? Yeah, and this is a huge area of like active development and research. Typically, if you want to kind of have an add-on to a microservice or an add-on to a container with Kubernetes, you'll do what's called a sidecar. So that is like a container that's deployed alongside, whatever it is, and augments it. It augments it for security, for proxying, your logging, your tracing. It's called, the design pattern is called a sidecar. But there's a bigger kind of architectural pattern called a service mesh, which personally I haven't used, I haven't needed. It's a pretty advanced topic, but well worth it if you're in an enterprise, looking to roll out a massive microservices project, and you want some sort of control, over the whole thing, and you want to be able to kind of roll out these cross-cutting concerns, across microservices. What you're after is a service mesh. I've heard Istio is good. I think, it's an open source project that builds on Kubernetes, so that is most likely what I would use if I felt the need for something like that. I've heard good things about it. If I don't think it's up at the level of Kubernetes. I'm not sure that it's graduated or it's a graduated cloud native project yet in the Cloud Native Computing Foundation, but it might be kind of moving through those phases. I don't know enough about it, sorry, but Google Istio. That is something that you can use to roll out, these cross-cutting concerns. Okay, I'm just trying to see if there's anything I've missed here in these questions. Oh yeah, so someone said, traffic is, handles SSL certificates for you. Cool. I use Cloudflare actually. I use Cloudflare for my startup for creating a proxy and creating SSL certificates. It just makes using secure HTTP, it makes that really easy to use. Hopefully I've got everyone's questions. I'm just scrolling through. I can't see anything else. Hopefully I haven't missed anything. Oh, can you say something about the CI/CD pipeline? I will definitely say more about that in talk 3. I'm going to actually, I'll probably give you a demo of a simple CD pipeline. That's usually how I start. Is I make a code change. I push the code change. It triggers the CD pipeline, and it triggers the deployment of a microservice to Kubernetes. So I use at the moment, a variety of different things depending on the project I'm working on. For my startup Sortle, I use Bitbucket pipelines. So, essentially what CD continuous delivery is, it's a shell script running in the cloud. Like it's not that complicated. That's how I like to explain it simply. You have an automated shell script running in the cloud whenever you push code changes. So you make some code changes, push it, triggers your CD pipeline, and you get basically your microservice or your web server or whatever you got, pushed out to production. So I'm using Bitbucket pipelines, but I'm also for some new contracts that I'm doing, and also for new kind of personal projects and prototypes, I'm using GitHub Actions, which is fairly new on the scene. I mean, it's probably been around for a couple of years now, but it's been through evolution, so it's changed a lot. But I'm really loving where it's at now. So GitHub Actions is just a great option for doing continuous integration or continuous delivery. I thoroughly recommend it. Does that help? But please feel free to come back in talk 3 where I'll actually give a demo and we'll look at some code for a CD pipeline. I'll actually show you code. Cool. Okay, guys, I think that's about all we've got time for. Her contract first design pattern in designing is that like contract driven testing or something? I'm not really sure what that means. All right, I'm gonna send out the codes now for the people who have won. So hold on for just a moment. Sorry, I'm just trying to find where I put these the codes for the giveaways. Just give me a moment. Okay, so the first one we're giving away is to George. Please take a copy of that code. And the second one I'm giving away is to Tuba. Sorry if I've pronounced your name wrong. Cool. So that's 2 copies of the book given away to George and Tuba. Thanks so much. What you need to do to recover that, to use that code, is go to manning.com, sign into manning.com, get a copy of my book basically in your cart, and when you go to purchase it, make sure you use that code, and you should get it free. If you don't, if there's any problems, please feel free to reach out to me. I'll put my contact details in the chat here. So you can direct message me on Twitter through Ashley Davis 75, or you can send me an email, ashley@codecapers.com.au. And that goes for anyone. If you want to talk tech, have a chat, ask a question, please feel free to get in touch with me. And yeah, let me get you the link for my book again. Hang on a sec, just let me copy it. So if you follow that link, you will get to the book. That's on Manning's webpage. You can read the first chapter there for free, or if you want a free copy, please enter your code, grab a free copy of the ebook. Otherwise, use the code that I put up earlier to get a 35% discount. And I'll be putting this all online as well. So check out my Twitter feed, or check out the meetup where you found this talk in the first place. And later on today, hopefully, you're going to see the video, a link to the video, and you're going to see a link to the slides, and you're going to see a link to the book and all that. So thanks for listening, and I'll see you for talk 2, hopefully. Bye-bye from Australia.